Hello and welcome to this session. Now, what this is going to be about is how I have been able to solve real life engineering problems using the theoretical knowledge that we were taught in school of engineering. And so it's actually just going to be an application of all the engineering knowledge that we already know. You know, because I noticed that there is a big gap between what we're taught in school and the application of it. A lot of people don't really know how to apply, the knowledge that we've acquired in engineering school to solve real life engineering problems. So this channel I created so we can go through, my own experiences and how I correlated the real life engineering problems or challenges with theoretical knowledge. So just a quick introduction of myself. I'm going to be making these videos in different series. My name is Elho Doguje, and I hold a bachelor's in mechanical engineering. I hold 2 masters, one in mechanical engineering, all in design, and also an MBA in project management. I am a chartered engineer, and I'm a member of the Mechanical Institute or the Institute of Mechanical Engineers. I have over 13 years experience in different engineering design fields, and that is my picture to the bottom left of your screen. So let's move on now to the next slide. Right, so what we will be designing in this first video in the series is an 8 kilowatt hybrid inverter system. It is a solar generator, and this is the setup. Now, there are several problems here, and we're going to be running through the problems that or the problem that I was trying to solve, and the thinking or the rationale behind my coming up with the solution, the strategies that I decided to adopt, and so on and so forth. So everything you're going to get in this video series, and the objective of this is to find a solution to a real life problem, and to find a solution that everybody can afford. So in other words, there is a problem, and the problem is the problem of power, and then there is also another problem, in addition to the problem of power, and that is the problem of affordability. So let's start with the problem statement here, and the problem statement is that there is no power, steady power supply where I grew up. I grew up in Africa, and we have this problem, in a lot of countries in Africa where the power is not just stable. So what is the solution to that? That is an engineering problem. What is the solution to that? So the solution includes several solutions anyways that has been developed over time, and we have machines, diesel and petrol electricity generators that we use. Now, these ones have they can be expensive to buy. The equipment depends on the horsepower of the engine you're looking for, and the running cost is for diesel and petrol generators is where the problem is. It can really pile up easily, and you cannot run that for 24 hours. It's not just possible, because you just be burning so much fuel. It's incredible. And if you have to carry a lot of load, the cost can really pile up very fast. So it's a viable solution, but it's not cost effective. So again, the second solution is, okay, if these countries with power problem then develop a better power supply solutions for the country, but that can take decades to materialize. So again, you cannot rely on that. especially in Africa where you have a lot of, unreliability in the government. The third one is wind power. Wind power is good where you have a place where you have a good flow, of wind, and places like that are, at times offshore or onshore where you have this land and sea breeze, this difference in temperature that results in the wind from one area forcing themselves into the area where you have lower air pressure, and you have that flow. So in those areas you can get good wind supply. But in areas where, like in city setup where you have buildings everywhere, you can hardly get that, except you take your wind mill and let it be very high above buildings, then you can get some flow of wind. Again, the initial cost for setting up those systems are quite high, so again, not a viable solution. And then the third one is solar generators. Solar generators are my favorite here, or the ones that actually I selected, because although the initial cost can be high, but it depends on the kilowatt hour that you're looking for, your load, but you can modularize it, which is one of the solution or the strategy that I adopted. So the solution I selected was a solar generator, medium to high starting capital, which is okay. But then not a lot of people can afford even the medium to high starting capital, especially in places like or in countries that are in Africa. So my strategy was, okay, let's modularize this. What I mean by modularize is, like a Lego toy, you build them into different parts and then you just assemble together. So modularizing in the sense that if I have, say for example, the total load in my house is 10 kilowatt, to be able to power everything for 12 hours from 6 in the evening to 6 in the morning, then if it is 10 kilowatt, and I cannot afford a 10 kilowatt system, what I'll do is to go for maybe a 5 kilowatt system or even a 3 kilowatt system. Then I will only load, then my loading strategy will be that it's not everything that I'm going to load, and I'm going to also discuss the loading strategy that I applied in my system. So this is the strategy that I'm going to be showing everybody here. I'm going to be showing you how to calculate your load. I'm going to be showing you how to modularize the system in such a way that how should I put it? In such a way that everything will run automatic, because I did my whole system to run automatic. There's little to zero interference from humans. Because with humans there's going to be a lot of errors. So if you have a 10 kilowatt system that you want to design or you want to install or you want to build, but you cannot afford it, your whole load in your house will require a 10 kilowatt system, but you cannot afford that. The strategy I'm introducing here is go for a 3 kilowatt or go for a 5 kilowatt, whichever one your money can afford, but you're not going to load it to the same capacity as a 10 kilowatt. You're just going to load, you're going to put just some load on it. And then you will use devices that will control this automatically. I'm going to show you how to set it up, that everything is going to run on an automatic basis. So that is it for now. So what I'm going to be doing is I'm going to break this up into several series so that the video they don't get too long, and so that you'll be completely engaged in it, you'll enjoy it, and then you see that although the solar generators system has a high starting capital, but there are ways and strategies you can employ to mitigate that so that you don't spend too much money. You can spend just what you can afford. So that's what we're going to be doing in this series, and I hope you enjoyed. Thank you.